Hey everyone, welcome back to BugNoJutsu, where we break down coding problems into simple, crystal clear explanations. In today's session, we're tackling a classic, checking whether a number is a power of 3. It's one of those problems that seems straightforward, but it's perfect for sharpening your problem-solving skills and understanding loops better. Let's dive right in. We're given an integer n, and our task is to determine if it's a power of 3. That means n should be expressible in the form n equals 3 power x, where x is an integer greater than or equal to 0. For example, 3 power 0 is equal to 1. 3 power 1 is equal to 3. 3 power 2 is equal to 9. 3 power 3 is equal to 27. If n matches any of these numbers exactly, then it's a power of 3. And here's the first filter. Powers of 3 are always positive, so if n is 0 or negative, we can instantly say it's not a power of 3. Let's walk through a quick example. If n equals 27, we start listing powers of 3. 1, 3, 9, 27, and at 3 power 3, we match the input, so the answer is true. Now, take n equals 45. The sequence goes 1, 3, 9, 27, then the next one is 81, which is already greater than 45. Since we skipped over 45 without hitting it, we return false. In my approach, I start from 3 power 0 and gradually increase the exponent by 1 in each step. For each calculated power of 3, I compare it to n. If I find a match, we return true immediately. If the current power of 3 becomes larger than n, we stop, because powers of 3 only increase and will never come back down to match n. This gives us a neat and efficient solution without doing any extra work. The time complexity is O, log base 3 of n, because the power grows exponentially, so it only takes a few iterations before we either match or exceed n. The space complexity is O, 1, since we're only storing a few variables, no matter how big n is. Early stopping is a powerful optimization, don't loop more than necessary. While you can solve this with a logarithmic formula in constant time, floating point precision can cause small errors, especially with big numbers. This loop-based approach is safe, easy to read, and works for all integers. Thinking about how numbers grow in patterns can help design efficient solutions. And that's the complete breakdown of the power of 3 problem, explained the BugNoJutsu way, clear, direct, and beginner-friendly. If you enjoyed this explanation and want more problem-solving tutorials, make sure to like the video, subscribe to BugNoJutsu, and hit the notification bell so you never miss an upload. Thanks for watching, and I'll see you in the next one.